the fact tables and dimension tables, let's go ahead and see if our Docker setup has been complete. So, oh, it's still pulling, so it's gonna take a little bit. We are almost there. While we wait for that, do you have any questions? Please let me know in the comment section, or I guess live chat on YouTube. Okay, no questions. All right. So when we think about data warehouses, the main type of kind of processing is are joins and group bys. So typically you have some fact table, which is orders in this case, joined with customer table, multiple dimension. Here we are just using one dimension, and group by certain kind of dimensional columns. So we use year and ID and name of customers, and we present some numerical number. That's like the standard analytical data pattern. So that's why joins and group bys are crucial. While I wait for this to start up, I do see a question from Tomin. What's the advantage of using strictly SQL versus PySpark Spark data frames? Is it just purely preference based? There are a couple of concerns. SQL is more widely used because it's understood by more people. However, if you want a more strict approach to programming with things like testing, encapsulation, etc., you would generally use PySpark. In my opinion, one of the biggest benefits is that when you use PySpark data frames or Spark data or Polars or Pandas data frame, you get IntelliSense in your code when you type code. So that's really helpful. You can also have type hints in Python specifically, and it's easier to test. And it's easy to kind of separate out code, so you're not looking at this like giant SQL at a time. So there are some benefits of using kind of a data frame based approach. However, SQL is also quite prevalent because a lot of people understand SQL, and it's also well established. It's been there for decades now, and most times it's a mix of both. It's not purely SQL or purely data frame. Typically, people do like simpler ones in SQL, convert it to a data frame, and send that as an output of a Python function. So it depends on the team, but usually it's a mix. Okay, so let's go ahead and open our Jupyter notebooks. So please click on Ports tab here, and you'll see this 8888. And if you click on this kind of open in browser button next to it, that will open a new tab. This is going to be our Jupyter notebook where we are going to run all our exercises. So go ahead and open notebooks. Go to notebooks and click on advanced join group by IPython notebook, and not the solutions one. That is for solutions for when you have time to look at the solutions. All right, so let's go ahead and set up the data. So basically what we want, actually let's open it in Jupyter Lab. That's a little bit better. And if you click on this icon, you can have a table of content, which is quite helpful here. So let's go ahead and set up data. These are basically some scripts that create TPCH data and generate the tables that we're going to use. And this is installing an extension which will kind of use to display the images. So let's go ahead and run these. All right. So we saw what fact tables are, we saw what dimension tables are, and we went over the join types and the kind of like a standard join query here. But let's kind of look at a pictorial representation of it, right? So what's happening here is you have a fact table called orders, you're joining it with customer table, which is a dimension, and you get some results. So you match, you group by, and you present some sort of result that might be used to power a BI dashboard or be sent to an Excel. That's like the standard data pipeline operation. However, in addition to the standard use cases of joins and group bys, they can also be used to find issues with our data set. So for example, joins specifically can be used to find differences in data set. You might have always used joins to be a way to join data sets, but there are techniques you can use by which joins now actually help you find differences. So in this workshop we will cover that mostly, because I assume you know the standard ones, standard joins. So the first one is called an anti-join. This is basically if you have a problem or a logic where you want to get rows that are present in one table but that are not present in another table, how do you do it, right? I want to take 5 minutes and give you guys 5 minutes to kind of try these problems out for anti-join. The first one is, let's assume you have an orders table and you have a line item table. Each line item should be associated with an order, but assume there is some issue with the ingestion and you have to figure out which are the orders that don't have any line item. How would you do that? We have a query here. I'll put like 5 minutes on the clock. Please go ahead and kind of write your query here. You should get these two order keys, 02 and 04. And if you have any questions, let me know in the chat. So there is a question asking, with anti-joins, do we care about columns from the table as well? I'm not 100% sure what you're asking, but if you're asking, do we care about columns from the other table, in our case, line item table, usually no, because we are only looking for table or rows that are present in one table that are not in another table. So that's basically what it is. Anti-join will only give you, in this case, the order rows from order table. It will kind of ignore everything from line item table. Does that answer your question? Just as a hint, there is a join called anti-join, like literally anti-join, just like left join, inner join. There is anti-join in Spark, so you can use that to write this query. And don't worry if you can't solve it. We will also have the solutions with everything solved so that you can kind of do at your own pace. I'm just gonna keep that open on the side just so you know there are solutions, so you don't have to worry if you're not able to do it right now. Let me know if anyone completed this and you're able to get 02 and 04 order keys as the results. Oh, the codespaces does take a while to set up. That's fine. I mean, you don't have to kind of write the code in here. I guess you could just imagine how the join query would look like. That works too. Okay, time's up, but basically the idea was literally this, where we are saying, hey, you have orders, give me everything in orders table that are not in line item, and we match by order key. So what this will do is look at every row in orders and give you the rows and orders whose order keys are not in line item. This is similar to a not in clause, but we want to use anti-join because this is a simple join. When the join is more complex, an anti-join will be really helpful compared to a not in clause. All right, the next type of join is called a as of join. I have a question, Tomin. So basically just a left join. Yeah, that is basically what it is, Tomin. So here I have an alternate approach as well. It's a left join with order keys null. And again, one of the benefits here is just a simplicity of usage, and the main pattern here is just knowing that this type of join exists. The next one is called an as of join. So if you have two fact tables and you want to get the data from one table as of a specific time in another table. So this is very important. This is as of specific time. Based on the closeness in time, right? Usually when you need to get the this is used when you are like matching two facts by time of some sort, like when did this happen versus what was the state of this other table at the time that something in table A happened. Most people call this point in time join as well. So let's look at a quick exercise here, right? Let's assume you have a stock table and you have a price tracker table, and stock table is basically the stocks that you bought on the date you bought it, right? So that's like symbol, like Apple, and listing date is, you can assume that's when you bought it. And then you have a price tracker table where you can assume every day there is some sort of system that logs the pricing, right? Hold on 1 minute. There is a issue. Give me 1 minute, please. Is the screen visible now? Are you able to see the screen better, Raghav? Is anyone else having issues with the screen clarity? Okay, great. Yeah, sorry about that. Not clear what was happening. Anyways, as I was saying, as of join is used to yeah, okay, there we go. As of join is used to identify when a certain event happened typically. So in our case, let's say you have the stock table, which represents your stock that you bought on a certain date, and then you have a price tracker table where you have the price listed for every date. This join will allow you to kind of figure out what the price was when you bought it. So for example, right, in this Apple case, in this Apple case, let's say you bought it on 2024 115, and you have the Apple price tracked for every day. You want to pick the price closest to your date. So we luckily have 2024 110 being tracked, so that's what we want to join. We don't want to join on 120 because that's after our purchase date. A way to do this is using something called an as-of join. However, Spark does not have that natively. Things like DuckDB do. And in this case, what you would typically do is a join, like a standard join, but you will have something called a range join. So instead of doing a direct join, you will identify all the listing before, all the price tracker information before your listing date, and then you will use window function. So you will say like, hey, sort by price date in descending order and give me the latest one. So a combination of joins, picking all the price tracker before the date you bought your stock, combined with row number function and tracking to 1, will give you the most current, the most as of time information. This is a bit complex. Some DBs again have as of join, so things like DuckDB, I think Trino has it as well. So if you are ever faced with a scenario, make sure that your DB does not have as of join before recreating it in with window functions. I'm gonna skip this exercise for now because we are running low on time. The next one is joins represent also check on foreign key relationship. So what does that mean? That means let's say you have a warehouse system and you don't control the ingest times, right? And you have like multiple tables landing at random times at different times. If you do an inner join, you will end up with losing data because a table A might have arrived in like 5 minutes, whereas table B might arrive 6 hours late, meaning the rows that are present across both will not be available if you do an inner join. So let's look at a simple scenario. I wanted you to think about these things, and it's not necessarily a query thing, it's more about thinking through this problem, right? Let's say you have a warehouse and you have 2 tables, orders table and customer table, and orders table is ingested every 5 minutes, whereas customer table is ingested every 6 hours. How do you ensure your joins between orders and customers don't lose data and is as expected? So if you have any questions or thoughts, let me know in the chat. It's more of a scenario type question, it's not a straightforward answer. So yeah, let me know. I'll put like 5 minutes on the clock. So again, the question is, if you have 2 tables arriving at 2 different frequency into your warehouse and you do a join on those, you are going to lose data. How will you approach this problem? And how do you think about tables that arrive with different frequencies? So Tommen says you need to ensure you have some sort of table load date column for each table and then join that along with any other relevant keys. Let's think through that, right? So you're saying we have a table load date. So that's a common pattern. So we can have something like ETL ingest date, right? And you can say like only give me rows that are available at that time. I'm not sure how that would work, Tom, and you can have an ETL ingest date or insert date, right? Could you specify that join that you would do? Because even if you have the ETL specified date, you will still lose data if you do an inner join. The next question is, sorry if I'm mispronouncing your name, Olsgun. Is this a SED? Let's assume that's a really good point. If you have an SED, which for people who are unfamiliar, it's slowly changing dimension. I'm assuming you're talking about two. That's a good point where you can specify the exact time period for when to join. That will give you correct joins. However, the same issue remains, right? Orders will have more data than customers. So if a customer was created like an hour ago, they will still not be in the SED table, right? And they might have made an order. But now if you do the join, even with an SED table, you won't be able to join because it'll result in no join. And yes, you will need special logic to handle orders without. Yeah, that's correct, Andy. You will need special logic. I want to get to that. That is basically the answer, like what the special logic is, and I'll get to that after the next question. Shah asks how to predict which column we have apply Windows function for any general. Okay, I do cover window functions in another bootcamp, but not on this one. Window functions are a little bit tricky. It needs a lot more time to explain what it is. So coming back to your point, Andy, you are right. Special, yeah, you're exactly right. Special logic does depend on the business requirements. So let's take a look at this, right? This is basically the kind of mermaid diagram, right? You have order data stream that comes in 5 minutes, customer data dump comes in 6 hours, depending on the join. If you do inner join, you will lose customer data, you will lose orders data as well, and that might be fine for your reporting use cases, especially with things like finance type stuff where you need more specific numbers. That might be fine. However, there might be reporting use cases where directionality is more important than completeness. In those cases, something like a left join would be better. So if you see the top here, you can see customer name is null. So it's like that's fine. In some cases, that's totally fine. Ideally, it's like, you typically think of it in one of 3 ways. You can do a left join with nulls being tagged as unknowns, meaning your orders will have a customer ID that is still not present in the customer dimension table. That's a possibility. You can just mark it as unknown, and this is like from Kimball style processing. The second option is to do an inner join where if you need more complete data, more specific data, you typically want to do inner join so that you only give complete data. Then there is the final pattern where you do an inner join or left join at the moment, but then you reprocess the same time frame of data at the end of the day. So it's like multiple processing. That's what companies typically do when you want to have both kind of like a fast data and also complete data later in the day. So typically you have like a pipeline running every hour, and at the end of the day you would just like process the entire day's data. It is common, but it's also quite tricky, because if I'm a user and I see this report or whatever every hour, and then suddenly the next day numbers are significantly different, it causes a lot of chaos. So that is a trade-off that you have to think of when you're using this multiple pipeline approach that modifies the same data set. So please be mindful of that. So Sandeep says you can use something called change data capture to store data in the staging area and apply logic for SQL from staging. That's a really good point. So for people who don't know, change data capture basically captures every change in your upstream data. So like every create, update, and delete in your customer table will be logged as individual rows in the CDC dataset, and we can use that to model like SED2 or a more recent give a view that gives you the most recent view of a customer data. So that is an option we can do, but in some cases, depending on the company you work for, different teams control different parts of the pipeline. So there's like a typical kind of ingestion team that dumps data into our warehouse. Sometimes it might be that they haven't had that chance to do CDC. So you can use CDC If you have the ability to use it, that would be ideal, which means like more complete data. But if you don't have CDC, you have to do the sort of like trade-offs to figure out what to do. Yes, sure. We can use change data capture in any data warehouse. Change data capture, it's more of a pattern than a specific tool. So you can, if you're ingesting data into BigQuery, you can do change data capture. Typically, you want to have like a mini batching mechanism before you insert into a warehouse. So like wait for like some sort of 1,000 rows or 5-minute timeline and then dump the data. That's just so you avoid creating too many small files, but I won't go into that more than that for this part of the workshop. Hello from SQL in healthcare department. Now the SQL in healthcare is kind of heavy on the privacy stuff, so I worked a little bit with those. It's pretty intense with the privacy, HIPAA compliance and stuff, so good for you, Nelikant. Any other questions? Okay, all right, let's move on to the next one. So we saw how we can use joins to get data not in a table, get data as of a specific time, and then finally how joins kind of expose underlying differences in data and also, excuse me, saw how to deal with those differences. And then finally, there are some kind of common caveats that we need to think about before we do joins. So the biggest issue I've seen is people use tables who have multiple different grains. So this is a issue with data modeling. If your data model is incorrect or you have multiple grains for the same table, your joins are just going to blow up and it will not work. So make sure your tables have a single grain, or at least filter them so that they do have a single grain before joining. Excuse me. We just went over handling slow and fast data joins based on use case. It's a complex one. It might seem simple at first, especially the path where you have to reprocess the data multiple times. That's a tricky one, because if you send out data to a stakeholder and it changes later, there will be a lot of questions, there will be confusion. Some cases it's illegal, especially in finance cases. So yeah, please be very, very careful with that. Then there's the issue of null key joins. So let's say you're doing some join, and in this example, right, you're doing some join on ID and some value, but if the value is a nullable value, meaning nulls are allowed, it will not join. Null literally represents an absence of value. It means, from a data modeling perspective, that there is no data. It doesn't mean anything. It just means there is no data. So null typically cannot be matched with null. However, in Spark and some other data warehouses, you can do a null safe join with this kind of special format. I think it depends depending on your database, but in Spark SQL it's this. In PySpark it's equinull equals. There is a function for this, but it should be a last resort, because if you're joining on nulls, that usually means your data model is not correct, because nulls represent absence of data. You should have either like replaced it with something like unknown or things like that. I typically tend to stay away from null join because it causes a lot of confusion well, later on if you need to debug your pipeline, especially this combined with like reprocessing pipelines that we saw before, where you are reprocessing the same time data for the same time. It'll cause a lot of confusion. So please be mindful of that. And then finally, the last point, it's not necessarily incorrect, but it causes issues with your database engine not being able to optimize your query plan. If you apply functions as part of your join criteria, what happens is any possible optimizations, such as partition pruning, figuring out clustering, etc., will be avoided, right? So if you have like, this is a very naive example, a lot of data warehouses handle this, specifically Spark and Iceberg, but if you have something like your function in your join criteria, sometimes the database engine might get confused and not apply any optimizations that it would have otherwise applied. So always try to kind of apply the function before your join, like a CTE or a subquery, and then do the join. That way you're not kind of ignoring any optimization patterns that your DB engine might be applying. So this is a simple example where we create two kind of naive CTEs, ID1, some foo value, ID2, some null value, similarly ID1 bar, ID2 null. If we use just an equal to, this will not give you any results. However, since we are using the null safe equality, we will get none, which might be okay for your use case. Typically I tend to stay away from it, but this is an option we have. Excuse me. Before we go on to the next section, which is group bys, I'll set like 5 minutes for any questions you have. Alright, there is one from Nelikant. I want to learn SQL for healthcare department and pharma department basic. And so I think that's a interesting question, Nelikant. I think I almost think of it as two separate things, right? One is SQL, the other one is health and pharma department. In my opinion, what's more important is that understanding the business processes, because I know the health and pharma is like super complex, a lot of human involvement, so a lot of cases for data errors. So I think, in my opinion, the first case would be kind of understanding what data you're working with, that and how that data is generated. That is more important than kind of like the hard skills of SQL as a first step. Akshay asks, what database do you suggest to store time series from IoT devices? What's your data scale, Akshay? If it's a few hundred rows a minute, Postgres would be fine, but if it's like a few million rows an hour, then you might have to think about something different. Oh, yeah. Million rows an hour? Okay, yeah, so Postgres will not work for a million rows an hour, because if you have a million rows an hour, that's 24 million in a day. That quickly goes into trillion, whatever, it's over trillion a day. Yeah, 8 TB a day. Yeah, that's probably not a good idea with Postgres. If it's 8 TB a day, what type of analysis are you running on it? Would be a question, but a typical pattern that I've seen a lot of companies use for analyzing large amounts of similar data, which I'm assuming IoT formatted data, is typically ClickHouse. Or Druid, more popular one is ClickHouse. So those are things that are optimized for storing large amounts of time series data. So what they do is they do pre-process your data. That way, when you're doing aggregates, it's already ready to go. So you can almost think of it as like sort of like a materialization pattern that they use. But yeah, ClickHouse is what I would recommend you look at. Cool. Is there any other question? You're welcome, Akshay. Are there any other questions? All right, seems like done. Is anyone having issues with codespaces setup? Oh, Andy has a question about my paid course. Oh yes, thanks Andy. I am releasing a advanced Spark SQL for data engineers. So that's specifically aimed at people who want to, one of three things: get a lot of familiarity with how to use window functions, and like what are the nuances, when to use them, when not to use them, how it impacts performance. And then the second one is what was it? I forget. Let me open that. The second one is Spark optimizations. So we'll learn like how distributed systems work, and how specifically Spark distributed system work, and how you can optimize your jobs based on Spark UI, Query Planner, and how to spot like bottlenecks and within your Spark processing, things like that. It's, I would say, anyone under like 5 years of experience or less years of experience, but or more years of experience, but not really super familiar with like the Spark optimization techniques, like how to do partition, when to do partition, what is the difference between partition and bucketing, what are some techniques, how do you sort it, why do you sort it, how is data stored, etc. So it's a little bit more on the technical side for sure, and also like covers like how to write idempotent pipelines. So one of the key things that I have noticed at my job and all my previous decade and almost a decade is like, when you run pipelines multiple times, which generally happens when you have to do like backfills and such, there's always some issues. So one of the topics I'll be covering is in the paid workshop is how to write idempotent pipelines. That way, you know, even if you're rerunning pipelines, like our case with this kind of reprocessing joint pipelines, we shouldn't create duplicate data. We shouldn't create partial data. So those three things. So okay, TLDR, it's meant for people who are looking to up their Spark SQL game, writing better window functions, idempotent pipelines, Spark optimizations. So yeah, and you can take a look at the course link that I'll post in a bit. I hope that answers your question, Andy. I went on a long rant. Nelikant asks, when take SQL Healthcare certificate? I do not plan to do a specific healthcare course, Nelikant, so sorry, I cannot get access to healthcare data, so I'm not going to do that. Shah is asking about country I'm from, job situation, upcoming speculations. Yeah, I'm not gonna. So I'm in the U.S. in the New York area. The job situation is not gonna like super rough right now. There are not a lot of openings. Even the ones that are open are expecting quite a bit. So you do need to put in a lot of effort. And then your question also includes question about upcoming job market. Well, I have about 10 years of experience, so take that into account. I have been getting more recruiter reach outs recently in the past month and a half, but it's nothing compared to what it was during the COVID time. It's rough goings. One thing I would say is go through recommendations if you have any, or try to find people who would refer you, because that is the most easiest way. I did like 3 interviews last year. I got all 3 through referrals. So yeah, I think referrals is the way to go. If you're applying, there are like hundreds of people applying, it's hard to get through. You need to kind of circumvent that somehow, and referral is in my opinion the best way. And also be ready for your interview, right? Like Python, SQL, some data processing, how partition works. I would be surprised at how many people don't understand partitions with like highly technical roles. I hope that helps, Shah. Do you have any other questions with that? What does my day-to-day look like as an expert? Well, thank you actually for calling me an expert, but mine, so it depends on the company. I worked in like companies where we didn't have data platform, and I was setting up the data platform. I worked in companies where data platform is like well established, and I was building more like pipelines and additional tools. Right now, at the level I'm at, it's more about excuse me, planning. So and kind of making sure any work that is being done is actually helping the stakeholder. So things like conducting user surveys, making sure for the next 3 months we have some sort of project that can deliver measurable outcomes. So that is honestly most of my day. I do write code. I would say about like 50% coding, 50% kind of project management type stuff. All right, we are running low on time, so let's go on to the next part, which is group bys. Typically, you use group bys to kind of produce some report, create a metric for your downstream consumers, etc. But group bys can also be used for validating assumptions about your data, right? And also creating some nested data structures, and finally, creating Excel-like pivot table style reporting. So let's look at that. The first use case of group by, besides reporting and standard use, is checking distribution of data. So when I'm exploring an input data set, I always try to do this to see if the data makes sense. So in this case, right, I want to set like 5 minutes for this. I want you all to kind of run this query and tell me what you think from the data, right? The data, I think my kernel is dying, but basically the data will look something. I don't have it here. Yeah, it will just get your nation name and number of customers for that nation. Look at that data and let me know what you think about that data set. Does it make sense? Is something incorrect with the data? Just does it make sense? That's like 5 minutes on the clock. And please let me know if you have any questions. I think something is happening with my okay. That's fine. While we wait for the code spaces to start, let's continue here, right? Did anyone get an answer for this group by? And what do you think? Please let me know in the comments or chat. Alright, something is off with the codespaces stuff, but basically what you can see here is when you run this query, you will see nation name, and China will have the same kind of number of customers as the rest, which should not make any sense because of the number of people there. So those sort of kind of issues are what you typically want to look for. So let's go look at what this would look like, right? Okay, while that's happening, let's go on to the next one. Again, you don't have to do this right now. We can always do it when you kind of get home, right? So there is something's happening. It's fine. Yeah, I think it restarted the whole kind of machine. Not sure why, but let's keep going. The other use case you would use group by is to identify primary key constraints. So if you have a table and they say like, hey, this key is the primary key, you can use group by to validate that. And here's how you do it, right? So you can do a group by your primary key and do a count star with the having. So what this does is it'll group by your primary key or supposed primary key and figure out if there are any primary key rows that are repeated. So that's what this having does. So that's a common use case of group by as well. Cool, let's go to the next one. So we have all heard of like the standard group by functions, which is min, max, average, sum. But in addition to that, there's also like more type of group by functions that not a lot of people use. Those are like statistical function, collection functions, approximation function, and convenience functions. So statistical is like if you want something like standard deviation or correlation, you would typically have those there. And then there's like collection functions. So those are things like array aggregation, collect all the rows into a single set of rows. You can use this to create nested data types, which are things like lists, dictionaries, etc., are called structs. And then you can use approximation functions. So these are basically like count distincts, but so much faster, because just count distinct is really slow due to how it's being computed in a distributed system. Approximation functions give you relatively right answer, but it's so much faster because it uses like a probabilistic data structure underneath it that makes them so much faster. Things like hyper, log, etc. And then there's the convenience aggregate function. So let's take a look at a convenience function, right? So this is like a typical kind of aggregate function where we are saying, hey, if order priority is low, count that, otherwise don't count it. So that's what this kind of complex logic represents. However, if you look at your database documentation, that you might have something like count if. So this can be represented simply as this, and that's just one of the examples, right? Then there are more, like are any of end rows true? So you can use things like boolean and boolean or that's specified here. So those are the 4 types of aggregate functions that I recommend you think about than just the standard ones. The idea here is, instead of recreating complex logic in your code, always make sure that your database documentation does not have, check if they have any of these already available. Cool. And then the next one is, I'm not going to cover this because we are running low on time, but essentially the idea is like you can combine multiple rows into one, and that's basically the nested structure right here. You combine multiple line items into a list of structs, which you can think of it as like a list of typed dictionaries. In addition to that, in addition to standard group bys, you also have these things called group by variations. So 3 key ones are cube, rollup, and grouping sets. If you are familiar with pivot tables in Excel, cube is similar to that. Basically, if you say cube region category on here, you can see like the exact group by unions that you would end up doing. Similar with rollup. Rollup is a little bit different because if you say region category, it will do like region category, region, and nothing. So we'll go over techniques on how to make your pipeline idempotent. And then finally, optimization. What are the key concepts of optimization? How distributed system data processing works? How do you interact with distributed storage? and how do you use like Query Planner and UI to optimize your data processing code. And then finally, storage patterns. So what's the difference between partitioning, bucketing, why sorting matters. So I think that if you know like the basics of SQL and or data frame as well, and you want to kind of take your skills to the next level, that's what this is meant for. And this will all be done in Spark SQL, and you'll get the code and everything. And yeah, it's next week. It says 4 hours, but don't worry, that'll be like a 15-minute break between each section. Format is led by me. Where there'll be a meeting link that I'll send if you register, and then it'll be recorded and available through Podia, runnable code, and kind of community Q&A. Yeah, I hope that helps. Actually, the next question is AI in data engineering. That's a good one. I have been playing around with it and have used it a little bit for work. The main area that I'm seeing it is, first of all, writing SQL for non-technical users. So when a non-technical user has a question, you send it through AI, it'll generate a query and give it to them, they can run it. The next thing I have seen is also writing documentation. People are trying to do that, but it's kind of terrible in my opinion, because all it does is literally just take the code and say this is what's being done. However, the true value of a documentation is giving context. Anyone can, if I'm reading a documentation, I would rather read the code to understand the logic. The documentation is there to give the context as to why a certain thing was done a certain way. LLMs don't do that yet, so it's a little bit of a letdown. Where I do see it being significantly used and very, very powerful, and I use this all the time, is all with unit testing. I tell it how to test it, what are the tests to run, it just generates a bunch of unit test code. That is where I've seen it work really, really well. Everywhere else, in my opinion, and I have 10 years of experience, so take that in mind, it creates me more work than I would have done if I hadn't used it, besides for testing where it's very helpful, or like repetitive code scaffolding, but it doesn't do anything innovative in my opinion so far. It might change in the future, which I don't think so, but yeah, I hope that answers your question. Actually, Tom and asks, oh, you are just curious. Yeah, the cross apply, people don't generally use it as much. People, I mean, in bigger companies as well, right? People try to keep it as simple as possible. You'll be surprised at how scrappy a lot of the big companies are, and how a lot of people don't fully know all of these things that we are going over as well. So yeah, I hope that helps. Any other questions? We are a little over time though. Yeah, Shah, this is mostly going to be on the US time zone. I don't have it specifically for Indian time zone. It's gonna be like an afternoon, so I'm not sure if people from India can actually join. Yeah, I do plan to kind of have it as like a recording. That way, that'll be like a separate recording, because in the online workshop, I'll be staying online after the workshop for a few hours to answer any questions as well. Any other questions? Okay. If there are no questions, oh yeah, thank you, Utla, for attending. I appreciate your time. It's a weekend, so I appreciate it. Thanks, Domin. Alright, I'm gonna end this if there are no more questions. Thank you, Sandeep. Thanks, everyone. Bye-bye. Sure. I don't have anything specific for GCP, but all of the content that I try to put out should be kind of tool agnostic. So Spark, tool agnostic. I mean, you can use Databricks, you can use like, I don't know, like EMR or whatever you want. SQL, this is also tool agnostic. I know BigQuery has a lot of these. There's a separate repository called BigQuery Utilities that give you access to all this stuff and more. Yeah, and when I went over kind of this part where we go over idempotent pipelines, query patterns, these apply to all data warehouses, not just specific to BigQuery. So yeah. Thanks, Jose Nildo. I hope I'm pronouncing your name right. All right. Thanks, Shah. All right. Thanks, everyone. Bye-bye.